Have you ever wondered what linear algebra actually is? Matrices, vectors, formulas. But what do these things actually mean? We can't start with matrices. We go back to the beginning. Let's build it from the ground up.
Everything in mathematics starts with quantities. Real numbers, imaginary numbers, constants, variables. These are the basic objects we work with. Now, what do we do with these quantities? We add, subtract, multiply, and divide them. The moment we start applying these operations to quantities, we enter the world of algebra. Algebra is the language that helps us describe patterns, relationships, and unknowns. But mathematics has another major branch, geometry. Geometry is the study of shapes, space, and their relationships. For centuries, algebra and geometry were developed almost independently. Then came one of the greatest ideas in mathematics, the coordinate system. By placing a graph over space, every point could be represented using numbers. Suddenly, geometry became algebra. Shapes could be written as equations, and equations could be visualized as shapes. This completely changed mathematics because now we could solve geometric problems using algebra and understand algebra by simply looking at graphs. In other words, two completely different languages became one. Now consider this equation, y equals x squared. It can be written as an equation, or it can be drawn as a curve. Both describe exactly the same object. Similarly, y equals et is an equation and also a curve. Even a simple line, y equals mx plus c, has these two representations, an equation and a graph. Two different views of the same mathematical idea. In linear algebra, however, we focus on a special class of equations, linear equations. Why? Because they are the building blocks of much more complex mathematics. A single linear equation is easy to solve, but in real life, we rarely deal with just one equation. Instead, we often have dozens, hundreds, or even millions of linear equations interacting with one another. Writing and manipulating all of them individually quickly becomes messy. So mathematicians invented an elegant representation, a mathematical interface that organizes entire systems of equations into one compact object. That object is called a matrix. A matrix doesn't create new mathematics. It simply gives us a clean and powerful way to represent and manipulate systems of linear equations. Now let's look at geometry again. Suppose instead of describing only positions, we also want to describe direction. For that, we introduce vectors. A vector tells us both how far and which way. To define direction clearly, we first introduce unit vectors, vectors whose length is exactly 1. They serve as the basic directions from which every other vector can be built. Using vectors, every point in space can be represented as a combination of directions. Now something amazing happens. Matrices describe how systems of linear equations behave. Vectors describe positions and directions. When we combine matrices and vectors, we get linear algebra.